Good afternoon, students. Hello. Students, can you hear me? Can you see the screen?
Yes, sir.
All right, good. All right, so I sent these questions. I sent some instructions for you to do some of these questions for revision purposes. You will get the best out of this session if you actually do the questions first before I do them. All right. If you if you don't do them before I do them, you still need to go and do them after I do them. And I'm recording the session so that I'll share the video at the end of the session so that you can look back at anything you got wrong, anything you misunderstood. Or if you did not do it, you can use the video as a guide to do it yourself. You just have to keep practicing. All right, so I'll give you 4 questions to do. That's a quadratics question. That's the functions question, the algebra, etc. question, and this coordinate geometry question. So we're doing these 4 today. And then for tomorrow now, you're going to be doing these. I set the instruction for tomorrow as well. So you're going to be doing that one, linear programming, this matrices. They're going to skip page 2 and go over to page 3. And we'll do the first 2 questions on page 3, which is this transformation. And then you're going to do this vectors. All right, so that is for tomorrow. All right, we're focusing on the first 4 questions on page 1 today. All right, so let's do this. Let's get into it. All right, so this is a question on the screen on the left. I'm going to be working out on the right. All right, so this question says we have to solve these 2 equations simultaneously. So this one is a line and this one is a curve, and it's actually a quadratic curve and a line, and so there are 2 points of intersection. All right, they can be 2 points of intersection if they intersect. It can also be a tangent. It can also be 1 point of intersection, like that. In that case, the line is a tangent. But CSEC won't send you the case where they don't intersect at all, which is another possibility. But we're solving them simultaneously. Now, the beauty about this one is that both are expressed in terms of y. Y is the subject on both. And at the point of intersection, this expression that is y on the curve is equal to this expression that is y on the line. At the point of intersection, the x values are the same and the y values are the same. So if I show the curve again and the line, I'm trying to find these 2 points. The x, y value at this point is the same on the curve and also on the line. Same thing over here. The xy value on the curve and the xy value on the line is the same, and we're trying to find these 2 points where the x and the y values are the same on the curve and on the line. So one way to do that is to actually equate them. Put the curve and the line, the y value on the line and the y value on the curve, make them equal. All right, so that's the approach we can use. So this is it, and this is not the only way to do it, but this is a good way to do it. So the curve is y equals x squared minus 3x minus 12, and the line is y equals 2x minus 16. So at the point of intersection, this y and this y equal, and the curve is saying y equals this, and the line is saying y equals that. So if the y on the line and the y on the curve is the same, it means then that this is equal to that. All right, so that is what happens at the intersection. Right, so at intersection, when we solve equations simultaneously, you find the point of intersection anyway. All right, so remember that as well. So at intersection, the y on the curve and the y on the line is the same, so we can equate these 2 things. So we can equate x squared minus 3x minus 12 to the y on the line is 2x minus 16, because the y on the curve and the y on the line is the same at the point of intersection. Now this becomes a quadratic equation, but it's not in a standard form. It's in a basic form. And we always say don't solve basic. You want to leave 0 on the right side. Alright? You want to get the quadratic expression equals 0 before you try to solve. So we need to take these and transpose them over onto this side to leave 0 on the right side. So this is our x squared term that is there. That's x squared. Think of it now. We have a minus 3x. It's going to come over and become a minus 2x. So minus 3x and minus 2 become minus 5x. Alright? So we're going to get a minus 5x. And then this is a negative 16. But this, negative 12, sorry. But this 16 now is going to come over and become a positive 16. And a positive 16 and minus 12, same as 16 minus 12 is 4. So we're going to get a plus 4 right here now. Equals 0. Alright, now there's a question down here that is testing our ability to factorize. Where is it? Is it there? Down here. So when I get to this, I'll go through the process of factorizing. Alright, so I'm not going to go through the process with this one that we're doing. The question is not testing our ability to factorize. So I'm just going to factorize this straight. And this is the factorize in a sense as well, because one of the factors of x squared is x and x. X and x. And then factors of 4 that add to 5 is 1 and 4. Factors of 4 that add to 5 is 1 and 4. I always know is add because this coefficient is a plus. It means that I'm adding the factors to get the middle term. So it's 1 and 4 are the factors. And then this tells me that the two signs in the bracket are the same. And this tells me what they are. Both of them negative. Here and here. So it's a negative 1 and a negative 5. Negative 4. Those are the two factors of this expression. You can test it because remember this times this gives you the x squared. Negative 1 times negative 4 gives you that positive 4. Then the middle term here now is the sum of the far product and the near product. The near product is negative 1x. This times this. And the far product is negative 4x. Negative 1x and negative 4x, they add to the middle term of negative 5x. So you know that they have factorized this correctly. Alright, so that is it. But as I said, I'm not testing that now. So if x minus 1 times x minus 4 equals 0, then either the x minus 1 is equal to 0. Now if the x minus 1 is equal to the 0, and you try to find x, just take this negative 1 and carry it over, it becomes a positive 1. So one value of x is that x equals a positive 1. And again, if this x minus 4 is equal to 0, then you can take this negative 4, bring it over, it becomes a positive 4. So x equals 4. Those are the two x values where the line and the curve meet. But we're not finished as yet. We have to find a y value to go with this and a y value to go with that. So we always substitute in the easier equation, which is the line equation. Most times the line equation is the easier equation. So we're going to substitute in that equation to find the y values to go with each of these. So we're going to sub into y equals 2x minus 16. So we're going to put x equals 1 in there first. When x equals 1 at this point, the y is equal to 2 times 1 minus 16. That's 2 minus 16, that's negative 14. And so 1 point of intersection is 1 is the x value, negative 14 is the y value. 1, negative 14. Then at the other point, the x is equal to 4. So at x equals 4, you plug in the 4 in the line equation again. It's going to become y equals 2 times 4 minus 16. Now, 2 times 4 is 8. 8 minus 16 is negative 8. So the second point of intersection is this is the x value 4 and this is the y value negative 8. And so that's your solution. So these two, that's one solution, that's the answer. And that's the other one, second point, that's the answer. And that is it. Are you okay with that first question? Are you good? Any questions on that? Are you there?
Yes, sir. Yes, sir.
Okay. All right. Let's go to the next part. Part B. Part B wants us to write this expression in this form. That is to complete the square. Now notice they put a minus h. Most times they give a plus h, you know. And some teachers teach it with the h and the k. But they teach it with the h when this is a plus. So because this one is a minus, you have to be careful. Right? That's a minus. Right? Because most teachers teach h equals b over 2a. But this is when this is a plus. That's why I prefer to use my xtyt because I want to get around when they change how they express this thing so as not to get you confused. Alright, so they give y equals x squared minus 3x minus 12, which is the same curve from before. And we are going to use y equals a into x minus xt, if you remember, squared plus yt. And xt is the x value at the turning point, yt is the y value at the turning point. So a quadratic function can be written, or a quadratic expression can be written in this form, which is called the standard form, or it can be written in this form, which is called the vertex form, or the turning point form. And this turning point form is the same form really as the x minus h that they give us, plus k. Alright, and this normally has an a in front of it. But this time the a is 1, that's why there's no value there. Most times they don't put a minus here, they put a plus. But this time they put a minus, alright? But this is what they normally give. Alright, normally you gotta give it in a different way sometimes. Now, when I use this format, the xt that we want is calculated using the formula minus b over 2a. Now, where does this b and this a come from? They come from the standard form, coefficients in the standard form. So, the a is always the coefficient of the x squared. In this case, there's no number in front of it, so that coefficient is 1. Alright, that's a 1. And the b is the coefficient of the x. Now, the second value now, the coefficient of the x, remember. So wherever the x term is, the number in front of it is the coefficient. So this is the x term, that's the number in front of it, so that's the b. The b equals negative 3. And the c is always a constant term out here with the sign. That's a negative 12. Alright, I'm going to use those values now to find xt and yt. So this is the formula for xt. Let's put the values on it. That becomes equal to, remember, write down that minus first. And then the b itself is this negative 3. So it's minus and negative 3. We can bracket it or we can leave it like that. All we know is that this becomes a plus. Minus minus is a plus. And then we divide that now by 2 times a. And the a is this 1 up here. So it's 2 times 1. And then this reduces to this minus minus 3 becomes a positive 3 over 2 times 1 is 2. So this is the value that is going to come right here for xt. And then the value coming here now, which is called a yt value, the y value at the turning point. T means turning point on the graph. Remember, the quadratic function is a turning point. The y value at the turning point formula is 4ac minus b squared divided by 4a. We're using a formula method to do this thing. There are other ways to do it, and it actually teaches another way at add maths and pair maths. But for this level, I tend to teach it this way using xt and yt. Alright, with the formula method. So I'm going to plug the values in here now. So it's 4 times a. The a is 1. So it's 4 times 1 times c. The c is negative 12 minus b squared. And the b is negative 3. So we're subtracting negative 3 squared. And that's all divided by 4a. 4 times a. 4 times the a. Remember the a value up here is 1. Remember now, we'll square this. We're not squaring this negative. This negative stays a minus, but it's not under the square. And so the yt value, if you simplify it, becomes 4 times negative 12, that's negative 48. Alright, yeah, negative 48, then minus, and that becomes a positive 9. Negative 3 squared becomes just a 9 over 4. And then this minus 48 and minus 9 become negative 57 over 4. And so that's the yt value that is coming right here for that plus yt. So we're now ready to write this vertex form. Let's go to the next page. So this vertex form right here is now going to become this thing. Y equals, now the A is 1. Can't put the 1 or don't put it. Let's put it for now. Into x minus xt minus, and the xt that we worked out is 3 over 2. So subtracting 3 over 2. Don't forget to put on the square for forming the perfect square. And the plus yt is negative 57 over 4. So it's minus 57 over 4. And we don't need this 1. So it is y equals x minus 3 over 2 squared minus 57 over 4. That's a vertex form. Alright? So I've completed the square, the first part. So I've completed this part, part 1. That's part 1 we just did. Part 1. Part 2 now is saying, hence determine the minimum value of the function, this function, and the value of x for which it is minimum. So it's xt and yt now. The minimum point is at xt, yt now. So from this function, the minimum point is xt, yt. Those are the values that we calculate. So the xt is 3 over 2 up here. See there, 3 over 2. And the yt is negative 57 over 4. Now, this yt value happens to be the lowest y value on the graph. And it is a minimum value of the function, the lowest value on the graph. And that occurs when the x value is 3 over 2. Because look at it, if this x value becomes equal to this xt value, then x and 3 over 2 minus 3 over 2 is going to be 0. Then your y value is going to become negative 57 over 4. That's why that is the y value at turning point when x equals that x value at turning point. And so we can answer this question, part 2. The minimum value. It's a minimum because remember, when it's a minimum, when is it minimum? It has a minimum value when the a is positive. When the a is positive, the graph is going to have a smile shape. So like the y value is coming down to a minimum, and then they start going up again. And this minimum point is the same point we spoke about here. That is a turning point. That's an xt, yt turning point. Alright? Did all of this in class. So the minimum value then is the yt value, which is negative 57 over 4. And then so we must take the value of x, which is minimum. So we can say which occurs when x equals the xt value, which is 3 over 2. That answers part 2. The last part says we have to calculate correct one decimal place solution for this. Alright, now when you see correct one decimal place, it basically saying that this expression cannot be factorized normally, right? Cannot be factorized in the normal way with integer coefficients and so on. You're generally going to use a quadratic formula to solve this, or you can continue from this. Some question actually forces you to continue from this expression. Alright, but we're going to use a quadratic formula because once you see correct the number of decimal places, it means you're not going to be able to factorize it using the methods that we do. Alright, so part 3, we're going to use the quadratic formula for it. Alright, so we have x squared minus 3x minus 12 equals 0. Same a, b, and c. The x is going to be minus b plus or minus the square root of b squared minus 4ac. Let's write that better. Remember, it's all, everything divided by the 2a. That's the quadratic formula. It will be on the formula sheet in the exam, but it's good to just know it in your head, right? So we're going to put the values in there now. So it's x equals minus, and the b again is this negative 3. Don't forget the sign. So it's minus and negative 3. Plus or minus the square root. This is b squared again, which is negative 3 squared. So notice I'm putting a bracket around the negative 3 because it's going to become a positive. Minus 4 times a. The a is 1 and the c is, let's say again, negative 12. Negative 12. And you're dividing everything by the 2a, which is 2 times 1. The a is 1. We're going to simplify this now. X equals, this minus is a plus. I get a plus 3. Plus or minus. So this plus or minus because you're going to get a 1 value with the plus and 1 value with the minus. Square root. Now this 3 squared is a 9. This minus 4 times 1 is negative 4. Negative 4 times negative 12 becomes positive 48. Plus 48. And you're dividing all of that by 2 times 1, which is 2. So you see you get about the same 57 over here. That's why I said we could solve it from this expression. Alright? We'll solve from that expression. And see the 3 over 2 that we have here is basically the same 3 over 2 formed by that if we were to break it out. But this becomes x equals 3 plus or minus the square root of 57 over 2. So it's one value with the plus and one value with the minus. I'm not going to bother to work it out. Well, yeah, I'm not going to bother to work it out. It will be x equals 3 plus root 50. I'm going to just do it. 57 over 2, or x equals 3 minus root 57 over 2. Let me just get the calculator and do it. And then I write them down over here. Where is my calculator? Right here. Let me do it right here. Alright, so it's a fraction. It's 3 plus root 57 over 2. So one answer to one decimal place is 5.3. If I change that plus to a minus, then it becomes negative 2.3. Correct one decimal place. So we can go back to the calculate the work and write x equals 5.3 or x equals negative 2.3. Those are two x values. Remember, when you solve a quadratic equation, you're finding the point of intersection with the curve and the x-axis. Alright? You're finding the roots. When you solve a quadratic equation, you're finding the roots. Remember, the same function, you know. So these two x values are the x values where the curve or the function crosses the x-axis. And here now, see, they're telling us to sketch a graph. Sketch it. They want us to sketch this graph now. Alright, so to sketch this graph, we're going to bear in mind the critical features. What are the critical features? One, it smiles. It is a turning point at 3 over 2, negative 57 over 4. Then the c on the function is the y-axis intercept. So the c is equal to negative 12. So the y-intercept is 0c, which is 0, negative 12. So it crosses the y-axis at negative 12. What else again? So this is where it turns. And we have the two roots, right? We have the two roots. So the roots are 5.3, 0, and negative 2.3, 0. Right? These are the two roots that we found a while ago. So see them here. 5.3 is the x value, and negative 2.3 is the x value on the roots. And on the roots, the y value is 0. On the x-axis, the y value is 0. So that's what we want to sketch and put in all those things, right? Because I want us to show the minimum point, which will be this. And I want us to show the x-axis intercept, which will be this. No, the y-axis intercept, sorry. And they want us to show the x-axis intercept, which will be these two. Alright, so let's sketch it now. Let's sketch it down here with this information. So, bam, 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 bam. Let's sketch it like this. Y-axis, X-axis, and just a sketch. So you don't have to be like accurate. As the question said, sketch. You just need to have the critical features shown. Let's draw it in purple. So, where would this point be where it turns? It will be where the x value is positive and the y value is negative. So the positive x value and a negative y value means that the turning point is somewhere down here. And the next question is, where does it cut the y-axis? The y-axis at 0, negative 12. No, 0, negative 12 will be somewhere down here, where the y value is negative on the x-axis, on the y-axis, negative y-axis intercept. So we need a curve that turns down here and crosses down here. Then it will cross the x-axis at negative 2.3 and positive 5.3. So it crosses the x-axis closer to the y-axis on this side where it's negative. Alright, so basically this is it. Turns down here, crosses down here, cut through here and here on the x-axis. So we're making a sketch. And basically this will be our sketch. That's a sketch. And this minimum point is 3 over 2 minus 57 over 4. This point is the y-axis intercept, which is 0, negative 12. And this was one with a positive one, 5.3. And this is a negative 1, which is negative 2.3. That is a sketch. But we'll go to that. I'm not going to do this question today because we did not cover any quadratic inequality in the class. I can just mention it still, no problem. No problem to mention this one. So this is basically saying this inequality is asking for where you remember this is y, that's a function that was equal to y, So basically asking where are my y values greater than or equal to 0. For what values of x will my y values be greater than or equal to 0? Now greater than or equal to 0 means they want above the x-axis. So on the x-axis, the y value is 0. Above the x-axis, the y value is greater than 0. Below the x-axis, the y value is less than 0. And on the x-axis, y value is equal to 0. This question wants on the x-axis and above the x-axis. Right? So which part of the curve goes above the x-axis? This part of the curve goes above the x-axis. Is a different color, black. And also this part of the graph. And those are up values up here, y values up here are obtained by x values to the right of this 5.3. Right? So you want your x values to be greater than 5.3. Right? And then now y values up here are obtained by x values down here less than negative 2.3. So you want your x values to be less than negative 2.3 as well. So the solutions are on these. Right? X is less than or equal to negative 2.3, and the equal to part is for the point on the x-axis. Over here, your x is greater than or equal to 5.3. So that is the solution. For that last part, solution of x squared minus 3x minus 12 greater than or equal to 0 is x less than or equal to negative 2.3 or x greater than or equal to 5.3 over here or over here. And that is its solution part. Question 1 done. But alright. Very good.
Yes, sir.
I'm going to watch over the video and read the question. So all you have to do, watch over the video and do it over by yourself. This is revision work. This is revision work, guys. All of these things we have covered in class already, except this last one down here. Alright, so we have covered A, B, and C. Alright, next question is a functions question right here. It gives us those two functions, of which one of them is rational and this other one is a linear. Let's see what it says. It says we must find g of 4 first. Now, g of 4, we're going to put 4 in the g function right there. That's g of 4. So let me write them out. So the f of x is a rational function 2x plus 4, 2x plus 5, sorry, divided by x minus 4. And g of x is 2x minus 3. Now, the first part wants us to find g of 4. G of 4 means that we're putting 4 in the g function. And so we're going to put the 4 in there here to get it, but really and truly putting it over here for the calculation. So it becomes equal to 2 times 4 minus 3. So 2 4 is 8. 8 minus 3 is 5. That becomes a 5. So g of 4 is equal to 5. And then part 2 wants f of g of 2. Remember, this means g of 2 first and then f afterwards. So we can work out the g of 2 first by putting the 2 in the g function right there. So this then becomes f of g of 2. And the g of 2, as I said, we put in 2 in this. So it becomes 2 times 2 minus 3. That's f of g of 2. Inside here is g of 2 right now. Alright, that's what we're basically saying. Now, g of 2 becomes 1. So it becomes f. And g of 2 is now 1. So then f of 1. Then f of 1 now means I want to put 1 in the f function here where the x is and here. So this becomes 2 times 1 plus 5 divided by 1 minus 4. This works down to be 7 over negative 3. Or negative 3 over 7, same thing. And that is the answer for that part 2. Are you okay with that? We'll move on. Very good. Somebody need to answer. If everybody's good.
Yes, sir.
Alright, part 3. Something we did in class again. It's asking us state the value of x for which f of x is undefined. In other words, which value of x cannot work on this function? Which value of x cannot be in the domain because it's going to make the function undefined. It's the value of x that will make the denominator equal 0. Okay, you cannot divide by 0 on a fraction. So the value of x that will make this undefined is the one that will make the denominator 0. So f of x is undefined when the denominator x minus 4 becomes equal to 0. You don't want the denominator to be 0. So it's undefined when x equals 4. So 4 cannot be in the domain of this function. Alright? 4 cannot be in the domain. Because if 4 is in the domain, it's not going to map to any value. And the 4 is going to be in there not mapping. And if 4 is in there not mapping, they don't have a function. Because remember, you have a function when each value in the domain is mapping and mapping to one and only one element in the range or in the codomain. And on a mapping diagram, it means that shows it is revealed by not having any element in the domain that is mapping more than one time or that is not mapping at all. Each element in the domain must map, and when they map only one time. Only one arrow must come off each element in your domain for that to be the mapping diagram of a function. Alright, so 4, because 4 wouldn't have any value to map onto, because 4 can't work on this function. I put 4 on this function right now. Let me show you. If I put 4 on this function, it's going to become 2 times 4 plus 5 over 4 minus 4. It's going to become, what is this? 8 and 5, 13. It's going to become 13 over 0. If you try this on the calculator, you're going to get an error message because you cannot divide by 0. Alright, so that is why 4 cannot be in the domain. Hence it will not be a function. Alright, so that answers part 3. Part 4 says we are to find f to the minus 1 as the inverse of this function and hence solve this. So this question is testing our ability, our knowledge of using inverse function to solve an equation. So it says find the inverse function first and then hence means use it to solve this. So if use the inverse function to solve that equation. But let's go. Part 4, we're going to find the inverse function first of f, right? Remember, when it's a rational function, there are a number of steps that I follow through the process. So using this function, inverse on this function. As usual, I want to call it f first. F equals 2x plus 5 over x minus 4. Then you want to get rid of the fraction. You want to separate out the values. We're going to inverse it first. So we're going to inverse it first. So when we inverse it first, this f which represents range becomes domain. And the x here and here each represents domain, which become range in the inverse function. So it becomes 2 times f to the minus 1 plus 5 over f to the minus 1 minus 4. So the range on the inverse function is written like that, f to the minus 1. Alright, we want to make the f to the minus 1 a subject now. So again, now we're going to have to expand it out into separate terms. Group everything with f to the minus 1 on one side in order to factorize and make it the subject. Alright, so let's go. So the first step always is take this denominator and multiply it across it by the x. So it's going to be x times this and then x times the negative 4. So what we're getting is x times f to the minus 1 and minus 4 times x. This times this first and then this times this next. Alright, and then the right side now this becomes this numerator. 2 times f to the minus 1 plus 5. And then now we're going to take this and bring it over here, pair it up with that one. I want to take this negative 4, bring it over this side and add it to the 5. So I want to get x f to the minus 1, that's this one. Then this comes over as a minus. So it becomes minus 2 times f to the minus 1 equal, this is 5. Then this first goes over and becomes a positive 4. Positive 4x. Alright, I'm going to factorize the f to the minus 1 out of these two terms. Alright, so we're going to get f to the minus 1 bracket x out of this one minus 2 out of this one equals 5 plus 4x. Then to leave this as a subject, now we'll take this x minus 1 divided under here. So we're going to get f to the minus 1 equals 5 plus 4x over x minus 4. That's our f to the minus 1 of x. Now that we're done, we can put in back the of x down here. F to the minus 1 of x. That's the first part, to find f to the minus 1 of x. So the next part now is to hence solve this thing. Solving 2x plus 5 over x minus 4 equal negative 1. I have to use this inverse function to do it. Alright, I have to use that inverse function to do it. Now, what you have to realize is that this really is our f of x that was given, f of x that was given up here. So this equation really is, so we can say, i.e., equation really is that f of x is equal to negative 1. I try to find the x. So to find this x, we're going to take the inverse f to the minus 1. So the x becomes f to the minus 1 of minus 1. So it works. Remember that if f of x equals minus 1, then the x equals f to the minus 1 of that negative 1. So to find f to the minus 1 negative 1, now we'll plug the negative 1 in this. Alright? Hold on. Alright, plug the negative 1 in that, right? So we're going to get x equals 2 times negative 1 plus 5 divided by negative 1 minus 4. That's what I'm going to plug the negative 1 in here. We get this. And we plug it down here. We get this. x equals, this becomes 5 minus 2, because it's 2 times negative 1 is minus 2. 5 minus 2 is 3 over negative 1 and negative 4, that's negative 5. That's the answer right there. That's the value of x. We use the inverse function to solve it. So this, the part of it is testing our knowledge of using inverse function to solve an equation. But I write it that. Very good. By the okay. I don't want to be just solving questions and nobody not paying attention. You know? Still a class, guys. You can go online, still a class. I need to know that you're there paying attention. So few of you come to the class today, getting me upset. Let's go. Let's go, let's go. Next part wants to find g to minus 1. And after we find, I must use it with the f to minus 1 to determine this. Alright, but let's find the g to minus 1 first. Right, let's write down f to minus 1 first. First we have the f to minus 1, we have it already. What was it again? We have it up here. It was this thing, right? 5 plus 4x over x minus 4. Yes, I make a mistake. It's x minus 2, you know, guys. I don't know, pay attention. It's x minus 2. X minus 2 on the here. So I make a mistake down here so as well. Down here, so I'm using f to the minus 1 of negative 1 is x minus 2 right here. So it's another says a negative 3. That's a negative 3. That's right though. So we're getting about negative 1. Make a mistake somewhere. Let's see if minus of negative 1. So negative 1 map on to negative 1. That's what this is saying. 5 minus 2. Let me just double check this guy. I don't like these numbers. If I put negative 1 in there, am I getting back negative 1 right here? Let me see. 2 times minus 1 plus 5 over minus 1 minus 4. Not negative 1, suppose that's 5 minus 2. 5 minus 2 is 3 over negative 5. Something wrong, guys. Let me find a mistake. There's a mistake somewhere there. Let me see. 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 2x plus 5 or x minus 4. I'm just checking, guys. Just checking. X times minus 4x plus that plus 5. I'm just checking. Minus 2 that goes on plus x minus 2. Then we do that's f to minus 1 plus 7 f minus. Oh, I see the mistake now. See the mistake. So I'm doing f to the minus 1 of negative 1, right? So I'm putting f to the minus 1 of negative 1 in this. Alright, I wrote the wrong thing up here. That's why it is wrong. See, your ability to find a mistake is also important, you know. So it's 5 plus 4 times negative 1. Because I'm putting f to the minus 1 of negative 1 in the f to the minus 1 function, which is this. So that's what it is. So let's see now the correct thingy. Now this is 4, negative 4. So 5 minus 4 is 1. 5 minus 4 is 1. And this is negative 3. So I accept that one better. Alright. I made a mistake along the way, but there you go sometimes. Use the wrong function, guys. Use the wrong function. That was that. Alright. 2 mistakes I made. Alright, down here now. So the f to the minus 1 is actually 5x, 5 plus 4x over x minus 2. 5 plus 4x over x minus 2. That's the f to the minus 1. I know they're telling us to find g to the minus 1. I'm just writing down this one first because we're going to need it. Now, to find the g to the minus 1, we're going to inverse this g function. Quick and fast and nice and easy. So g equals 2 minus 3, 2x minus 3. When I inverse it, the g becomes x. 2 times the x becomes g to the minus 1 minus 3. And to make this a subject, we're going to transpose the 3 first and get x plus 3. Then take this 2 that's a multiplying and divide it on a here. That leaves us with g to the minus 1. Alright, so we can write g to the minus 1 of x now is x plus 3 over 2. We have these two functions now, right? And the question wants us to use those two functions, this and this, to find this. That's the inverse of a composite function. Now, what we have to remember now, inverse of a composite function, I'm going to put a different color for this part. So it is that gf r to the minus 1 is equal to these two, switch around, these two in here, switch around, becomes f to the minus 1 of g to the minus 1. That's what it becomes. Alright, now the order here, the f is second, over here it is first. Here the g is first, over here it is second, the inverse is second. And this is done by substituting the g to the minus 1 into the f to the minus 1. So it means then that I'm going to take this and bring it and substitute it here for the x, and again substitute it here for the x. That's what we're going to do, right? That's why I put g to the minus 1 into f to the minus 1. So we're going to get 5. Let's go for the purple. 5, and it's minus 4x. No, it's plus 4x. So it means that this whole function is coming with x's. So it's 4 times that thing. Over, the denominator now is x minus 2. So we're taking this and put it for the x right here. And then we go ahead now and subtract these two. And I'm going to simplify it. I'm not interested in simplifying it right now. I just want to show how you do it and remind you of this thing. So this is what I really wanted us to revise, right? That is it. Alrighty, that is it, guys. I have to keep just revising and practicing and so on. But let us do the next part B. This is to write that as a single fraction. So I have to put the algebra. And it is 3 over x plus 4 over x plus 1. That's an algebraic fraction. And when you're adding algebraic fraction or a numerical fraction, the process is the same. You want the two denominators to be the same. So what you can do is take this diameter and multiply it up here and multiply it down here as well. And then take this denominator, multiply it up here, and multiply it down here as well. So let me show that. So this one is coming up here and down here. I multiply this one by x over x. And that's what that is. Let me take this and put a bit of x there. And then I'm going to multiply this one, numerator, I'm going to put over this side, by x plus 1 over x plus 1. Alright, and then simplify. Let's go now. Simplify. So 3 times this x is 3x. And 3 times 1 is 3. Divided by this times this becomes x times x plus 1. Plus, over here now is 4 times this x is 4x. Over x plus 1 times that becomes x into x plus 1. Now that two denominators are the same, we can cancel it in the numerator. So it becomes equal to 7x plus, no sorry, 3x plus 4x is 7x. 3 plus nothing is just plus 3 over this common denominator now of x into x plus 1. And that is it. We add those two fractions. Alright, let's look at part C. Part C gives us 9 to the half. Now this can be done with a calculator, you know. 9 to the half times 8 to the 2 over 3 times 4 to the 0. Now, this half power means square root because it really means 9 to the power 1 root 2. When you have a number raised to, when you have like a number, I'm show you. When you have a number raised to a power, which is a fraction, like that, it is the same as that number raised to the numerator becomes the power, and the denominator of that power is now the root. You can go the other way around, you can do the root first. So you could do the root first. This is the root, root n, r root of n, like this. The r root of n, and then you apply this power, which is just raise that to the power p. So you can do one of those two, right? When your powers are fractions. So let's get back to this now. This becomes equal to, so it's 9 to the 1, 9 to the 1, and this is square root, times, this one now is 8 cubed, no sorry, cube root of 8, and then square root, cube root of 8, and then square it to get that. And then you have to know that any number with the power 0 is 1, more things you know the better. This can be simplified. This is root of 9 right now, which is 3 times, this now is the cube root of 8. Cube root of 8 is 2, so it is 2 squared plus 1. Now this is in a plus and s times 1. So this is actually a 4 times 3 is 12 times 1 is still 12, so it's works out to 12. That finishes the functions. Question number 2. Very good. Remember, guys,
Yes, sir.
when we do the questions, watch over the video. We do the questions. This is revision time. Alright, it is revision time. Alright, so let's go on to this algebra question. All doing 4 questions on a nice short session. Tomorrow come back with another 4. Alright, and then Sunday with the 4, and then Monday with the 4. Alright, and then we look to see, we might be breaking now on Wednesday and so on, because we're getting closer now to the Christmas and so on, and I'll see when we're starting back. But let's do 4 today, 4 tomorrow, 4 Sunday, 4 Sunday, and 4 Monday. Alright, that is the plan. Alright, first part now gives us this algebra we're doing now. I want us to calculate the value of r and p is 6 and q is 12. So that's straight substitution. So the r is equal to 2p squared divided by q minus 3. It tells us that the p is equal to 6 and the q is equal to 12. One second, let me just take this call. 1 second. Hello? Yes? Yeah, who you came by? I don't understand. You came by my number. What is it about? By me? I'm supposed to collect it? No, I work at Grace. I work at Grace. You know, I'm not collecting any. Oh, it's Caymanas Golf Club. You're dropping it off. But I don't have any number there. I would expect them to give somebody who deliver to Caymanas Golf Club from time to time. I don't know where it is. I don't know where it is. Oh, Jesus. Yeah, but them shall at least let me know that some could if they know that you don't know where you're going, they shouldn't like to leave first and they give you my number and I'm here. You understand me in a sense? Yeah, but they do it wrong. They should have make you know where you're going first. No, not said no. I said they did it wrong. They should. So is it alone you're taking? I have you have another load. Hold on. Let me give you somebody's number you call. Maybe they can tell you where you're going. Let me give you somebody's number. Hold on a second. I don't want you to come back with it. Give me a second. Hold on. Alright, let me see if I can get somebody to call you. Yeah, hold on. Students, just give me a second, please. Give me a second, please. Give me 1 second. Let's do this. Oh boy. Lorraine, the person who's dropping off this thing for Caymanas Golf Club, he doesn't know exactly where he's going. You can call him for me and tell him where he has to go. He has a goods now. I give him somebody number there or something. I don't know. I don't know anything about the place. Call it. Let me give you his number. 424-8364. So what you can do. Oh, you can call the driver? Oh, alright. Maybe just come back with it then. Because that's what I've got to do. Because I don't know why Kevin give the man my number. Kevin should find it. Kevin know them don't know where the man is. Them should basically ensure that the man know he's going first, or we establish that first. And wait till the man out on the road, he might call me now. And I don't know where the place is. Alright. Alright, maybe it's time to come back with it. Alright. Alright, cool, yeah. Don't make any sense. Alright, everybody just bring it back here, because I don't know anything about out there. And we sort it out for tomorrow. Alright, cool. Alright, students, sorry about that. That was a work call. It happens. Sorry about that. Alright, so we are trying to find the value of R in this expression when P is 6 and Q is 2. So it's straight substitution. So the R at that point becomes 2 times the P is 6 right here. So it's 2 times 6 squared divided by the Q right here now is 12. So that's 12 minus 3. This becomes 2 times, this is 6 squared is 36 divided by this is 12 minus 3 is 9. We can also do some simple division here now. So 9 into 36 is what, 4 times? And 9 to that was 1 time, right? So that becomes 2 times 4 is 8. 2 times 4 is 8 over 1 is 8. And that is it. But good? Simple as that. Next one says we have to rearrange to make Q the subject. They want us to make Q the subject. So let's look at it again. I'm going to copy it down again. Let me copy it down. I'm going to transpose and make Q the subject. Let's keep it simple. Alright. So we want this thing to be the subject. So what we can do to make this thing the subject, we can take all of this denominator, multiply it up here, take this r and divide it under here as a first step, trying to isolate the q. Alright, so when we do that, we're going to get the q minus 3 as a whole equals 2p squared divided by the r. But understand that? Very good with that? And then to leave this q as a subject, now we'll just take this 3, bring it over here and add it. So the q becomes 2p squared over 2 plus 3. Now I'm not saying that that's the only expression that it could be, because he could have done another way that end up with q equals 2p squared plus 6 or all over 2. Could have ended up with that as well, and maybe even some other forms. Alright, but you know, that is basically it. Alright, we have made q the subject, so this is a r. How did I get this to be a 6? Because I will multiply this by 2. I will multiply this by a 2 and divide it by a 2. So they have the same denominator. And then this 3 times 2 is this 6 all over this 2. Alright, so that's another way we could have done it. So we could use this or that. And maybe some other forms, but that is it for now. Let's continue down to part B. Part B wants us to factorize these things completely. Keyword is completely. Alright, so factorizing these 3 things, 1, 2, and 3. Now the first one has 4 values there, 4 terms. So one is a factorization by parts or factorization by grouping. So it's this 3g minus 3t plus 2mg minus 2mt. When I'm factorizing, I will factorizing by grouping, right? Normally, most times the answers end up like that, those double brackets like that. So you're looking out for that, right? So the process really is, you look at the first 2 terms for a common factor, which is going to be a 3. It's okay, if I factorize the 3, I'm going to have a g and then a t. So you'll then look over here and see the g and the t is in that same order. G and then t, which they are. So because they are in the same order as the first 2 terms, there's no need to rearrange the values. You can proceed. Common factor in the first 2 terms is 3 into g minus t. And a safe thing to do now is to put by the same bracketed term over here, g minus t. And then now, you look at this and say, okay, if you divide that by this g, what will be factored out here now is the 2m, and it's a plus 2m. Remember, in between here, you must always have a plus or a minus value, right? Or expression. So this time is a plus 2m if you factor in the g. So it's in a plus 2m. And to ensure that it is correct, now you're going to multiply this plus 2m by the minus t over here to see if it gets that term, which it does. So you know that they are factorized good so far. So then the g minus t is a common factor and they are connected with this g, this 3 plus 2m. Alright, so it becomes 3 plus 2m connecting g minus t, and that is your answer, factorized completely. Alright, all good? Let's practice it, guys. Let's practice it. Alright, we have a quadratic now. I'm going to revise of how we do the process of splitting the middle term. So we have 3x squared plus 2x minus 8 to factorize as a quadratic, a trinomial, 3 terms quadratic. We factorize it by trying to break it out into 4 terms. So we can do the same kind of factorization by parts as we just did. So to break it out into 4 terms, the method that we practice is to split this out into 2 terms. And to find the right 2 terms to split that out into, we have a method that I call the AC method. We multiply this A value by this C value, and the C value carries that negative sign. So that would be 3 times negative 8, which is negative 24. Then now what it is that we are looking for factors of this negative 24 that add to the middle coefficient, which is a positive 2. Because we're searching for the 2 values that we're going to split this positive 2 into. And so we need factors of this negative 24 down here that add to negative 2. Now if you can't see that it is 6 and 4 off the bat, because 6 times 4 is 24 now. Just that one is going to be positive and one is going to be negative, so the difference of them is 2. But if you can't see that it's 6 and 4 off the bat, then you can go down the list of factors of negative 24. Now remember, factors of a negative number, one will be positive and one will be negative. You have to give the larger one the same sign as this. So getting a positive and a negative factor of the negative 24, give the larger one the same sign as this. If you cannot see what the factors are that you need right off the bat, you're searching for those factors. The first 2 factors of 24 is 1 and 24. Make the larger one positive as this is, make the smaller one negative, and you add these 2 values. So it's 24 minus 1 is 23. But it's not 23 we're looking for 2. So we're not going to use this result. The next 2 factors of 24 will be 2 and 12. Again, make the larger one positive and the smaller one negative, because I want them to add to this positive value. But then 12 minus 2 is 10. You don't want 10, you want 2. So you cross that off again. Next 2 factors of 24 is 3 and what? 3 and 8. Make the larger one positive, the smaller one negative. But then 8 minus 3 is a 5. No, your middle term is a positive 2, so you don't want 5. Next 2 factors of 24 is 4 and what? 4 and 6. The large one positive, smaller one negative. Good now, because 6 minus 4 is 2. So I found your positive 2. That's it. So it means that you're going to split this 2x into minus 4x plus 6x. Or any or the other way around. You can put the plus 6x minus 4x. That's what you split it into. Alright? So we're going to go now and we're going to actually do the splitting. So this comes back unchanged, which is the 3x squared. Then I said this now split out into minus 4x and plus 6x. Let's put the plus 6x first. So it's plus 6x minus 4x. Plus 6x from this factor, minus 4x from this factor. And then we'll get back this negative 8 down here. I must always check that what you split the middle term into would give you back the middle term, which it would. 6x minus 4x is 2x. And you're going to factorize the first 2 terms. Highest common factor in the first 2 terms right now is 3x. So you factorize the 3x. 3x out of this leaves you with an x. Divide this by 3x, you're going to get a plus 2. And what we remember now is that when we're doing this factorization, whatever is in the bracket here must be in the bracket here as well. So a safe thing to do is to write back the bracketed term first, x plus 2. So that's like a safety net. And you look now, what must be factorized out of this to get this? You can say divide it. That 4x divided. That negative 4 is divided by 4 is negative 4. Or you can use these 2. This negative 8 divided by this positive 2. Divide it to see what you're putting out here is negative 4. So whichever you want to look at it, you put in a negative 4 here. Then you again have a common factor of x plus 2 and they're connected with the 3x and the minus 4. So that's what you get. The 3x minus 4 connecting the x plus 2. And those are your 2 factors right there. But alright? Are you good with that? Is that okay? Alright. Then we come to 3x squared minus 27. Now this is a quadratic number, it's not a trinomial, it's just 2 terms there. So don't need a lengthy process. And whenever you get a factorization, you see a negative in there, you must think of the difference of two squares. Look for it. But initially what we have is just a common factor. And every time you have a factorization, it is not a quadratic, not a trinomial, you do your highest common factor first. Once there's a common factor that you can take out of all the terms, take it out first. The common factor here is a 3 from those two numbers. I'm going to do that first. 3. 3 out of this is x squared. 3 out of this is a negative 9. You have to look inside, you know, and see that them are factorizing further, especially with that minus. And yes, because this knows the difference of two squares, because it's a perfect square of x, that's a perfect square of 3. Let's remind ourselves of the rule for the difference of two squares in red. And this is it. A squared minus b squared becomes the difference of the numbers a minus b and the sum of the numbers a plus b. So what we're doing is write this 9 as 3 squared. And don't throw away this first factor of 3. 3 into, this remains x squared minus this becomes 3 squared. So this is like the a now and this is like the b. And we're applying the rule over here. Alright, so then it becomes the same factor first is 3. Then this now factorizes into the difference of these two numbers first, which is x minus 3. And the sum of those two numbers, which is x plus 3. And that is it. You're factorizing completely. But okay? Very good? Alrighty. Then we come to this expression here now, which is a simple linear inequality. This one. Simple inequality to solve. And we have to determine the largest integer of value x. And we have to write the solution set. And we have to draw the number line. So doing everything with this simple inequality. Now, remember, the simple inequality 3 minus 2x greater than is 11 is solved using the same steps as 3 minus 2x equals 0 equals 11. So for inequal sign, same steps as if it was an equal sign. The main difference with this one is that because it is an inequality, if there comes a point where we have to multiply or divide by a negative number, we have to remember to reverse this inequality sign. When you divide or multiply an inequality with a negative number, you have to remember to reverse the inequality sign. But it will be the same steps, it's almost the same steps as trying to make x a subject from this equation. Same steps. Alright, so this is not complicated. Just remember to reverse the inequality sign if you have to multiply or divide with a negative number. So that will transpose in everything away from this x. So first we're going to move is this 3, subtract it over here. So we're going to have the minus 2x left, minus 2x greater than, I was subtracting 3. That's what we're doing. We're subtracting 3 minus 3. That's what we're doing first. So we're subtracting 3 to get rid of this. We'll subtract 3 from this as well. Alright, or we can say bring it over and it becomes a negative 3. 11 minus 3 is 8. And if you want to look at it, this is now 8. Then to leave this as a subject, I need to divide by this negative 2. That's a negative number. Let's remember now. We're going to divide now by that negative 2. Because we know dividing with a negative number, we have to reverse. You have to remember this, guys. Reverse that greater than sign. Alright? Simply just reverse it. So you divide this by the negative 2, it becomes x. This sign is reversed to less than. Divide this 8 by negative 2, it becomes negative 4. That is your solution. Alright? And they want us to do some stuff with it. That's your solution and solve it. Then it says, determine the largest integer value that it can be. The largest integer. Now remember, if x is less than negative 4 and you want to list the values, then the x would basically be like equal to, can't include the, I'll put the number line first, might be more glaring on the number line. If I were to show this on the number line, right? Like this. So like I'm going to put 0 up here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, -7. All right, so I'm putting this on a number line. So the critical value is -4, which is right here. That's it, the critical value, right? But because the equal is not a part of the inequality, we're going to put a circle on the -4 that is not shaded. The unshaded circle means that you don't want -4 because it says the equal is not on it, so you cannot include the -4. To show that you're not including -4, you put an unshaded circle on it. If this, for example, is an equal, then you would shade the circle on the -4, which would then mean that -4 is also a valid number, a valid value for x. Right? But in this example, it's not, because the equal is not there. Then you want values that are less than the -4. And to show that on the number line, put the arrow pointing to the left, because values down here are less than -4. That's a number line for x less than -4 now. Alright? So this then includes values like -5, -6, -7, and so on, right? And you know that the value is getting smaller and smaller that way because they're negative. And that's why they ask for the largest value. And they're talking about integers, meaning we're only taking the whole number, because if it was not an integer, a value like, for example, right here, which is -4.2, for example, or -4.5, would be okay because it's still less than -4, right? But they want integers. The question is saying, okay, what if you only want integers? What would be the largest value of x? It will be this one, -5. Because if you wrote the integers, then x would be values like -7, -6, -5, and we can include -4. And this three little dots means that you go all the way down to -infinity. So this will be the largest value. Alright, so the largest integer, if x is an integer, remember integers are positive or negative whole number, right? Largest integer would be x equals -5. That's the largest one that x could be. Alright, so what have we done? We have, they want a solution set. So the solution set is basically when you put this solution in set brackets. So this is your solution. Let's write out some other things. This is your solution. This is a number line. This is your list, if you're listing the values. And the solution set now is when you put this solution in set brackets like this. Basically, put set brackets like this. Alright, x is such that, and basically writing about the same inequality. X is less than -4. So this is what we call a solution set. Solution set. So note those differences. You have a solution, which is what you get when you solve it, what was given. The solution set, where you put the solution in set brackets like that. And put that set builder notation. And then we have the number line. And they could have also asked you to list the values, something like this. You ask you to list the values, and that's if they were integers. Alright, so that is that for that question. But good. This is revision, guys. We're talking about some of the stuff that we spoke about in class. Alright, we're just going back over some of them. Spoke about all these things in class already, but we have to revise and review and go back over stuff. It's in the head there somewhere, so I just need to just bring them out again. Alright, so it's a variations question now. So remember, variation can be direct or inverse. Alright, so remember, generally speaking, direct variation means, like for example, the first thing is equal to k times the second thing, right? And inverse variation means that the first thing is k divided by the second thing, as simple as that. And you're trying to find the k. The method most times involves trying to find the k and then some other pair of values. And they must give you a known pair of values to find the k. They must give you a known pair of values. The question can be done without finding k, but we're practicing the method of finding the k first right now. When we master the method of finding the k first, then I show you how you can actually do this question without finding the k if the question does not require to find the k. But we're using a safe method first, which is to actually find the k, find the equation fully, and then use it to find anything they want us to do. All right, let's look at this question now. It says, y varies inversely as x. So straight y and x for this one. No x squared, nothing, no root, nothing, no nothing. No straight x and y. Could have been x squared or square root of x or something. But it's just a straight y and x, and it's an inverse. So it means that y is equal to k over x to begin with. If y is equal to k over x, when they give an inverse variation, a nice thing to do is just multiply this up here and get xy equals k. Now all this means, guys, that the product of x and y will always be equal to the same value. The product of x and y will always be equal to that constant value, whatever it is. And they must give us a known pair. If you look in this table, this is a known pair that they're giving us. That is to find the k. So it means that the k is 16. So it means that the product of these two numbers, all of them must be 16. The product must always be 16. The product of the x and y is always 16. So this time this is 16, this time this is 16. That's what happens. Why? Because the product of the first two is 16. Right? So this question is very easy. Alright, so as I said, this is to find k. I'm using that method, right? It says, use the values of x and y from the following table to calculate the value for a and the value for b. The product is always 16. So let's show it. So I want to find k first as our method. Find k first. I'm going to use this pair of values, known pair of values, to find the k, which is x equals 2, y equals 60, y equals 8, sorry. Put the two of them in here. Right? So you're going to get 2 times 8 equals k if you put the two of them in here. That is 16. 2 times 8 is 16. So the k is equal to 16. So it means that this equation now becomes xy equals 16 forever and ever. Amen. X times y will always be equal to 16. That governs everything now. So for this pair of value that they want the a, right? First pair of value that they want the a, you know that the x equals 32 when the y equals a. Product of them must be 16. Can you plug in them in this equation? So you know that the 32 times the a must equal 16 same way. Can you plug in them in this? So the a equals 16 over 32. If we divide this 32 on here, 16 over 32 is a half. So the a equals half, or 0.5. And then on the other pair here now, the x is b and the y is 24. Still the product is 16. Right? Let's divide it here. The x is b and the y is 24. The product of these two things is still 16. So you see there, b times 24, if you plug them in this equation, is equal to 16. So you're going to divide by the 24, you're going to get b equals 16 over 24. This reduces to what? This reduces to 8 into each of them. b equals 8 into this is 2 times, over 8 into this is 3 times. Can leave it like that for exact values. And we can put what this one as a half, as a fraction, half. That's a A and that's a B, guys. Product is always 16. That's it. Are you good? Nice, easy question. Nice, easy question. Alright, we're just revising. We're just revising. Come up here now. I want to do this one and we'll call it a D. Call it geometry. Nice and easy. Let's go. Alright, so this question gives us the point P is 2, 4. Gives us the point Q is 6, 10. This topic is centered on the knowledge of a number of formula, right? or formulae. If you remember the formulae, you're good to go with this topic. So part 1 is the length of the line. Part 1, length of the line. So length PQ is equal to, remember, it is a square root, comes from Pythagoras' theorem. It's the difference in the x values squared plus difference in the y value squared. Comes from Pythagoras' theorem, or the length of the line formula comes from Pythagoras' theorem. So it becomes equal to the square root, the difference in these two x values squared, 6 minus 2 squared, plus the difference in these two y values squared, that's 10 minus 4 squared. And then simplify, square root. This is 4 squared. 6 minus 2 is 4. 4 squared is 16 plus. This is 10 minus 4 is 6. 6 squared is 36. That becomes the square root of 52. I can leave it like that. Units. That's how long the line is. Square root of 52 units. Done. Next part wants the gradient of the line. Again, gradient now. Next part. Copy this. I cannot space it on this page. Let's copy it now. Same 2 points. Another one gradient, right? Let's put it here. Part 2. Now, gradient. When you have the two coordinates of 2 points, it's difference in y or difference in x. So the gradient, let's put common m for gradient of PQ is difference in y over difference in x. Because remember now, it is rise over run. And rise is the difference in y, and run is the difference in x. The only thing to remember with this now is that the direction you go when you take the difference in y, you have to go the same direction for the difference in x. You cannot change the direction because gradient has a direction component to it. So these are two y values. Take the difference of them. Let's say we're using this point minus this point. We're subtracting both times that direction. Q minus the p. Then it will become this y value minus this y value. That's 10 minus 4 divided by, we have to use this x value minus this x value. Subtract the x values the same way, same direction. 6 minus 2. That becomes 10 minus 4 is 6. 6 minus 2 is 4. Divide this by 2, we get 3. Divide this by 2, we get 2. Always simplify the lowest term. So that is the gradient of PQ right there. 1.5. Then we want the equation of PQ. This part wants the equation. I can do it right here. Everything's on the screen. Now, to find the equation of any line, remember we need to know two things about it. We need the gradient, which we have here, and we need a point. We have two of them. We can use any one of them to find the equation. And a good formula to know is what we call the BFF formula for the equation of a line. So the equation of PQ using the BFF would be y minus y value at P equals the gradient of PQ into x minus the x value at P. Some people refuse to learn this because they just stick on y equals mx plus c, and they use this as a gradient here, and then they use the points, coordinates here and there and here to find the c. All right, some people do it that way, but no problem. If you want to do it that way, fine. But I like using this method because I'm gonna get the equation straight away. We need to find out c first. The c will come out in the end. So this x and y represent a general point, so they stay in the equation, and then these now they come from your gradient and your known point. Could have used q, but I'm using p. All right, so those values, this and that, they come from this and that. All right, and get the equation. So it becomes y minus the y value at the p is this 4 right here. Y value at the point is 4. The gradient is this 3 over 2 into into x minus this x value point is 2 right here. X value point is 2. And then normally, because that's a fraction, I would take this denominator and multiply it across this side by those two. But because this time, if I multiply this by this number, I'm getting a whole number. I'm just going to multiply the fraction straight inside the bracket this time. So it's going to be y minus 4 equals 3 over 2 times x is 3 over 2x. But 3 over 2 times negative 2, 2's cancel and give me a negative 3. Then this 4 goes over and becomes a positive 4. 4 minus 3 is 1. So it's y equals 3 over 2x plus 1. There's your c if you wanted it. C is 1. So that is the equation of a line. Are you okay? Very good?
Yes, sir.
Alright, beautiful. Alright, let's paste this now. Paste same 2 points. And part 4 is asking us now for the midpoint. But the midpoint is an average point. Treat it like an average point, right? So the midpoint, just remember average when you take care of a midpoint. Midpoint. So the midpoint is like an average point, they're calling it M. So it's the average of the x values and average of the y values. So the midpoint is the average of these two x values, which is 2 plus 6. 2 plus 6 over 2, and the average of these two y values, 4 plus 10 over 2. That gives the coordinates of a midpoint. So the midpoint will be, now this 2 plus 6 is 8, 8 divided by 2 is 4, this 7 and 10 is, this 4 and 10 is 4, 4 and 10 is 14, 14 over 2 is 7. That's the midpoint right there, 4, 7. Alright, then this one says now, find the equation of the line through M, which is perpendicular to PQ. That is the perpendicular bisector of PQ. So instead of giving you the description like this, they could have asked for this, the perpendicular bisector of PQ. So it's a line that passes through the midpoint of PQ because this is a bisector, cuts it in half, and is also perpendicular to it. Let me do like a schematic of it, so you can see what I'm talking about. So it's like we have PQ, right? 2, 4, and 6, 10. Alright. 6, 10, 2, 4. So like you have a line like this. This is P, this is Q. And then you have the midpoint right here. We just found a while ago, M. And you want to find this line, the perpendicular bisector. Passes through the midpoint and is perpendicular to it. Let's call it perpendicular bisector line 2 so we can reference it. Line 2. That's what you want. It passes through the midpoint M, which has these coordinates, and is perpendicular. So the perpendicular is about finding the gradient. Remember, perpendicular lines have negative reciprocal gradient. Remember that the gradient of PQ, we worked out a while ago. Gradient of PQ, what was it again? 3 over 2, right? 3 over 2, right? 3 over 2, 3 over 2. This red line has a negative reciprocal gradient because they're perpendicular. So that's the part in red. The gradient of line 2, because the perpendicular PQ to PQ is minus 1 over the gradient of PQ. That's what we call the negative reciprocal. Now this calculation can be done quickly by flipping this and changing the sign. Flip the 3 over 2 and change the sign. That's a quick way to do a perpendicular gradient. So a line that is perpendicular to the line with a gradient of 3 over 2 becomes minus 2 over 3 because you flip the 3 over 2 and change the sign with it negative. So the gradient of that perpendicular line becomes minus 2 over 3. It here, flip it, flip the one that you have, flip it, and change the sign. So if it's positive, it becomes negative, if negative becomes positive. Flip it and change sign. That's what we do, right? To get the perpendicular gradient. So this is the gradient of this red line. and it passes through the point M, which is 4, 7. And that's all you want to get the equation. This is all you want for the equation. Gradient and a point. I'm going to use a BFF for it now. Let's write it back in red. So the equation of that line 2, perpendicular bisector, becomes y minus ym, because m is the point that it passes through, equals the gradient of line 2, the perpendicular gradient, into x minus xm, using the point m. So it's y minus the y value at the point m is 7, equals the gradient of the perpendicular gradient. This is negative 2 over 3 into x minus the x value at the point m is this 4. And then to simplify this, because this is not a perfect multiple of this, I'm going to take this denominator and multiply it across here by these two values. I'm going to take this numerator of negative 2 and multiply it in here by these two values. To simplify this quickly, so 3 times these two values first. So it's 3 times the y is 3y, and 3 times this negative 7 is negative 21, equals this negative 2 now I'm multiplying inside the bracket here. So negative 2 times this x here first gives me negative 2x, and then negative 2 times negative 4 becomes a positive 8. And you're going to take this 21 and transpose it over here and add it. So you're going to get 3y equals negative 2x plus 8 plus this 21 over here becomes a positive, and then 21 and 8 becomes 29. So we end up with 3y equals minus 2x plus 29. That's the equation. If you want to leave y alone as a subject to make it in the standard form, you can divide through by this 3 here and here. So if you divide through by the 3, you're going to get y equals minus 2 over 3x plus 29 over 3. That is your equation. But good? One more part still to do. But alright? But good. Alright. Then now, question says we'll find yet another line. A line that passes through this point and perpendicular to PQ. So how that one gonna know? So again, it's like we have the PQ right here. Let's put it down in blue. Like we have the PQ over here, like this. That's your PQ. And I want us to find this other line now that is purple. So I'm going to put it in purple. We want a line that is parallel to it, meaning they will run in the same direction, so they have the same gradient. But this line now passes to a point R, negative 2, negative 3. That's just a schematic in there, not necessarily accurate. So we're trying to find the equation of that purple line now. Let's call that line 3 so we can reference it. Now, because them parallel, then the gradient of line 3 is equal to the gradient of PQ. Because parallel lines have the same gradient, so that is just simply 3 over 2 from the get-go. And it passes through this point R. So it passes to the point R, which is minus 2, minus 3. And again then, we have the two things that we need to find the equation. Because remember, to find the equation of any line, you need to know those two things about it. The gradient and a point, that's all you need. The gradient and a point, we have them. So we're going to use the BFF. So the equation of that third line is y minus, the point is r, so we're going to say yr equals the gradient of line 3, which happens to have the same gradient as PQ, into x minus xr. R is the point, right? So it's y minus yr is the y value right here, which is a negative 3. So we'll be careful with these negatives now. So it's y, this minus is this one. And the yr itself is a negative 3. Negative 3. This minus minus is going to become a plus. And put a plus there in red for you. This minus minus becomes a plus. Over for the purple. Equals. The gradient of line 3 is the same as the original gradient 3 over 2 into x minus. And the x value at r now is this negative 2. So that's another minus 2. Again, this minus minus becomes a plus. Let's put a plus on there for you. Alright, and then just simplifying that now. If you want, just use this as y plus 3. So you're taking this 2 and multiply it over here, so by this y plus 3. Alright, so it's going to become y times 2 first is 2y, and then the y times positive 3 is positive 6. No, not the positive 3 times this 2 is positive 6. Equal, take this 3 now, multiply it inside this bracket. So it's 3 times x first is 3x, and then 3 times this positive 2 now is a positive 6 again, positive 6. So getting a positive 6. So positive 6 over here and positive 6 over there, then wipe out each other, balance off each other. So end up with just this 2y equals 3x. 2y equals 3x. So there's no c value. So it passes through the origin. And if you want to make y the subject, we divide by this 2. Get y equals 3 over 2x. There's no c on it. So when the c is 0, I should say c is 0, it passes through the origin. So that line passes through the origin because the c is 0. And that is that for today, guys. That is it for today. Very good. Very good. All right, so we are gonna. What is happening here? Okay, still on. Right, we're gonna end it there now. And as I said, I want you now to go and redo this question. I'm gonna send the video right away. Redo these questions. If you got anything wrong, or if you did not do the question, you redo the number 1 question here, the quadratics, you're revising. We do the functions. We do this algebra, factorization, inequalities, variations, and we do this coordinate geometry before tomorrow's class today. Then still before tomorrow's class, you're gonna do this linear programming right here. You're gonna do this matrices. You're gonna go over onto page 3. I don't need to do anything on page 2 yet. I'll tell you when to do page 2. You're gonna go over onto page 3. Or you can do page 2, but do this that I'm telling you to do first. Right? Before you do this on page 3, page 2, you're gonna do this question I'm telling you to do first. So come over onto page 3, you're gonna do this question, which is a transformation, this one right here. And you're gonna do this vectors question down here. A nice vectors question. Alright, and we go through those 4 questions tomorrow. Alright, and I can tell you from now on Sunday, it's gonna be that now we're gonna come onto page 2. We're gonna be doing this one, 2, this one make 3, and this one make 4. That's on Sunday. Then on Monday, we're gonna be doing this linear programming, this matrices transformation. We're gonna come back down here, and we do have to do this one because we actually do this one as a classwork already, if you remember. That's a classwork that we did. But we're definitely gonna be doing this one. Alrighty. So that is a plan for the next couple of days. But I want you to do the questions first. So when I do them, you'll see your mistakes, I learn from mistakes and what have you. Alright, guys. So work with me now, please. Work with me and let us do this, alright? And get some good revision over the break. Going into the new year. And we'll start back with trigonometry. Brand new. Alright, so I'm gonna send the video and just follow my instructions, please. Alright, bye everybody. See you all tomorrow.